To write the electron configurations, we are going to learn a method where we first draw a diagram that allows us to write the electron configuration of any atom. So here I'm going to write down 1 through 7. Followed by 2 through 7, then 3 to 7, and lastly 4 through 7. For each of these number lines, I'm going to write down the alphabet corresponding to our subshells. So we got the combination of the shells 1s, 2s, 1, 2, 3, 4 with the subshells s, so 1s, 2s and so on. Then we have the p subshell combined with the shells 2 to 7, and we got the d, and then we have the f. Now what we have here is the combination of shells and subshells. The filling order, as we know, we want to start with the lowest numbers. So the lowest combination, we are going to strike a diagonal arrow. Whatever we strike through from the upper left, as I just did, upper right, I mean, that I just did, whatever we strike through is what we fill up first. If we do it correctly, and it's not too hard, we will not miss a combination of shell subshell, neither will we strike over something twice. And here we are done. Now remember that S allows a max of 2 electrons because there is only one orbital. P allows a max of 6 electrons. D allows a max of 10 electrons, and F allows a max of 14 electrons. That said, let's say we want to write the electron configuration of the largest element with 118 electrons. And by the way, I stopped at 7p instead of going through 6f because we won't even need to get to 6f. Let's start with this element with 118 electrons, the last one, OG, organeson. We have to fill up the 1s up here, since we start with that, 1s2. Then we go into 2s, 2s2. Then we go into 2p, 2p6. Now notice what I'm doing. I have the shell, I have the subshell, and then I write down the number of electrons as a superscript next to the subshell. We do not state the number of orbitals anywhere here. The shell, the subshell, and the electrons. That is it. After 2p, we go into 3s. So we have 3s2. Then we go into 3p. See, after 3s, we go up here again. We go through 3p. 3p can take 6. Then we'd go into 4s. Did you notice that? Instead of going into 3d, we are going into 4s. Why is that? Because there are some exceptions on the periodic table, and this is one of them. There are many exceptions when we write the electron configurations, as you will see now. Then we go into 3d, and 3d can take 10 electrons. Then 4p, 4p is 6, 5s, 2. Then after 5s2, which was here, we go into 4d, 4d 10, followed by 5p, that's 5p 6 followed by 6s, that's 6s2, followed by, now we go into the F, 4f14, followed by 5d, that's 5d10, then 6p, 6p6, then 7s2, followed by 5f14, then 6d10, and lastly 7p6. Let's see how many electrons we got here, because the largest atom with the most electrons has 118 electrons. Let's count all of them. 2 plus 2 4 plus 6 10 plus 2 12 plus 6 18 plus 2 20 plus 10 30 plus 6 36 plus 2 38 plus 10 48 plus 6 54 plus 2 56 plus 14 70 plus 10 80 plus 8 86 plus 2 88 plus 14 102 plus 10 is 112 and plus 6 is 118. Now, if you were asked to write the electron configuration of some other atom with fewer electrons, let's say you were asked to write the electron configuration of an atom with 82 electrons, you could always draw this diagram. This diagram is not something I will provide to you. You must draw this and memorize the fact that each of the subshells here has this many electrons. Then you simply count, after knowing how the whole electron configuration should be, you simply count up to 82. So 2 plus 2 4 plus 6 10 plus 2 12 18 20 30 36 38 48 54 56 70 80, and because we only have 2 electrons to fill up, we do not need anything that starts with well, we do not need all of this. And here, instead of having 6p6, which would give us 80 plus 6 86, I would simply put 6p2 meaning 2 more electrons. So it is very easy to write the electron configurations of any atom. Furthermore, there is something called abbreviated electron configuration. Abbreviated electron configuration looks at the noble gas preceding the element for which you are trying to write the electron configuration. So let's say I am trying to write down the electron configuration of an atom with 42 electrons, right? Now 42 electrons means, let's undo this. We count from 1 through 42, 1s2, 2s2, 2p6, that's 10, 12, 18, 20, 30, 36, 38, and here we end with 48. So if it has 42 electrons, I would not need any of this, and here it would be 38 plus, since we ended up with 38 here, we just need 4 more, so it would be 4d4. However, on the periodic table, the noble gas that precedes this element with 42 electrons, that noble gas has 36 electrons. So we would put down the atomic symbol of that noble gas in a square parenthesis. What is that noble gas? Look up on your periodic table. That noble gas is krypton. So we would write Kr, krypton. Krypton has 36 electrons. So basically, when we write down Kr in square parenthesis, we are saying that we are starting after krypton, which already has 36 electrons. And that was 2 plus 2 4 plus 6 10 12 18 20 30 36 up to this point. Then the remaining portion we simply copy over as 5s2 4d4. So This is the electron configuration of the element, which has 42 electrons. And that element is, let's have a look on the periodic table, molybdenum, Mo. So we could either have written the whole configuration or the abbreviated electron configuration, which starts with the noble gas right before the element. Now it's not right before as in one step before it. You might have to move in the reverse direction. Whatever is the number of electrons for your element, go one less, then one less, and one less until you arrive at the noble gas, which is the last column. Whichever is the noble gas, copy it inside the square parenthesis and then write the remaining portion of the electron configuration. So you might be asked to write the full electron configuration like I wrote earlier up here, or the abbreviated electron configuration.